Every time you print a photo, a school project, or maybe even a recipe, an unseen show begins. Inside your printer, thousands of tiny droplets of ink leap onto the page in perfect patterns. It's honestly pretty easy to miss the magic happening in that buzzing gray box. But with every pass of the printhead, science and engineering work together in harmony. Most of us only see the end result, a sharp image or crisp text. We rarely think about how it gets there. Yet, if you could actually peek inside, you'd find a world of moving parts and split-second decisions. The process is quick, quiet, and almost invisible to the naked eye. Still, it relies on some of the most precise technology found in any home. This microscale magic isn't just a fancy phrase. It's a real description of what's happening. Ink droplets smaller than a human hair are shot with pinpoint accuracy. The result is something that looks familiar, but is built molecule by molecule. Next time you print, remember, you're watching a carefully choreographed ballet of physics, chemistry, and engineering. At the core of every inkjet printer is a simple but clever idea. Spray tiny droplets of liquid ink onto paper. But these droplets aren't just any drops. They are precisely measured, controlled, and aimed. Each droplet is about 1/10 the width of a human hair or even smaller. The printer's printhead is the star of this show. It holds dozens, sometimes hundreds, of tiny nozzles. Think of them as miniature hoses. When the printer receives a command, the printhead starts moving across the page. It carefully releases ink droplets at just the right spots. This process happens fast, sometimes thousands of times per second. The droplets need to land exactly where they should. Even a small mistake would blur the image or make text fuzzy. So the nozzles and the entire system must work in perfect harmony. By spraying micro drops of ink in precise patterns, the printer builds up text, photos, or art dot by dot. It's a bit like painting, but the brush is invisible and far more accurate. One of the coolest tricks inside many inkjet printers is thermal bubble technology. This sounds complex, but it's based on a simple idea. A tiny heater is placed just behind each nozzle. When the printer wants to fire a droplet, it sends an electric pulse to the heater. In an instant, this heater gets hot. It quickly boils a thin layer of ink, forming a tiny steam bubble. The bubble expands and pushes a droplet of ink out of the nozzle onto the paper. Then, the bubble collapses and new ink rushes in, ready for the next pulse. This cycle, heating, bubbling, firing, repeats thousands of times per second. Because the bubble is so small, it cools down almost immediately. This makes the process both fast and energy efficient. Thermal bubble technology is amazing because it uses basic physics, heat, pressure, and fluid movement, to achieve incredible accuracy. It also allows for building very small nozzles, packing more of them together for sharper prints. Printing isn't just about spraying ink. It's also about moving parts with perfect timing. Picture this. The printhead moves side to side, left to right, across the page. At the same time, the printer's rollers feed the paper forward, line by line. All of this movement needs to be tightly controlled. If the paper slips or the printhead wobbles, the image will look messy. So, the printer uses sensors and motors to keep everything in sync. The printhead doesn't just glide smoothly, it stops, starts, and accelerates, all at the command of the printer's brain. Software tells the printhead exactly where to fire each droplet. It also tells the rollers when to move the paper. Sometimes the head makes several passes over the same line, adding more detail each time. This careful dance ensures each dot of ink lands in the right spot. It's a bit like a robot painting a picture, with every movement mapped out in advance. So, you might wonder why printers use cyan, magenta, and yellow instead of red, green, and blue. Well, the answer lies in how colors actually mix. Screens use light, so they mix red, green, and blue, what we call RGB, to create all sorts of colors. But printers, on the other hand, work by laying down color on white paper, blocking light instead of shining it. This is what's known as subtractive color mixing. When you mix cyan, magenta, and yellow inks, they absorb or subtract certain wavelengths of light. The combination of these inks can create almost any color you see in a printed image. For example, cyan absorbs red, magenta absorbs green, and yellow absorbs blue. When you mix them, less light is reflected from the paper, which gives you new colors. By adjusting the amount of each ink droplet, printers can make everything from bright oranges to deep purples. Using CMYK inks allows printers to create a full-color image using just 3 colored inks. It's really a clever solution, and it's all based on the science of light and color. Now, if cyan, magenta, and yellow can make black, you might ask, why do printers bother adding a separate black ink? The answer comes down to quality and efficiency. Mixing all 3 colors gives you a dark gray, but not a true deep black. For sharp text and bold outlines, pure black ink is essential. Black ink, often called K for key in printing, gives you those crisp, clear results. Plus, it saves the colored inks for actual color printing, which makes the process faster and more cost-effective. If you only used CMYK to make black, you'd run out of color ink pretty quickly. Having a dedicated black ink really improves detail, especially for fine lines and text. It also helps prevent those unwanted color shifts that can happen when the colors don't blend perfectly. In short, black ink is the secret behind the sharpness of your printed words and the depth in your photos. Behind the scenes, smart software and clever algorithms control every part of the printing process. When you click print, your computer sends a complex set of instructions to the printer. These instructions tell the printer where to place each drop of ink. The printer's onboard computer takes over. It calculates the best way to mix colors, how much ink to use, and when to move the printhead. It even decides how to handle tricky images, like gradients or small fonts. The software can split a single color into tiny dots of different inks to make smoother shades. Algorithms also help spot and fix problems. If a nozzle is clogged, the printer can adjust by using another one. It keeps track of ink levels, printhead position, and even the room's temperature and humidity. Thanks to this digital brain, printers turn your ideas into real, high-quality prints without you needing to understand the science behind it all. You might have seen the term DPI in printer settings. It stands for dots per inch, and it's a measure of how closely the printer can place ink droplets. The higher the DPI, the more detail the printer can show. Imagine drawing a picture with a big marker versus a fine pen. The fine pen can make small, detailed lines, while the marker can only make broad strokes. In printing, a DPI of 300 is standard for clear photos, but some printers can go up to 1200 DPI or more for super sharp images. High DPI means more nozzles and faster printhead movement. It also means the printer must control each droplet's size and position with great care. Too much ink or droplets in the wrong spot will blur the image. By carefully controlling DPI, printers can produce lifelike photos, smooth gradients, and crisp text that look great even under a magnifying glass. Like any high-precision machine, inkjet printers face challenges. One common problem is clogged nozzles. Ink can dry out and block the tiny holes, especially if the printer sits unused for a while. This can cause streaks or missing lines in your prints. Engineers have built in clever solutions. Most printers will run cleaning cycles that squirt ink through the nozzles to clear blockages. Some models even use heat or vibration to shake loose dried ink. Others park the printhead over a special pad to keep the nozzles moist when not in use. Ink drying too quickly on the paper can also cause problems, like smudges or uneven colors. To fix this, ink formulas are engineered to dry at just the right speed. The printer might also slow down when printing on glossy paper to give the ink more time to set. By solving these tiny but tricky problems, engineers keep your prints looking perfect, page after page. Inkjet printers are more than just office equipment. They're a blend of fluid dynamics, heat, electronics, and color science, all packed into a small box. Each print combines thousands of tiny actions: ink firing, paper feeding, color mixing, and software control. The result is reliable, high-quality prints that look great every time. It's easy to overlook the science inside, but inkjet printers are a perfect example of everyday engineering at its best. Every droplet, every movement is a mini miracle of design and precision. So next time you print a photo or a document, take a moment to appreciate the hidden world inside your printer. Behind each page is a story of innovation, teamwork, and a bit of micro-scale magic. Without a doubt, the humble inkjet printer is one of the most remarkable machines in your home or office.